Okay, now we're going to discuss something that all of you've obviously heard of, and so we're going to kind of talk on a physiologic basis. This is another second line defense called a fever. Fever is an archaic process. Even with lower forms of animals, fevers occur. In snakes, which are cylindrical and have a bad surface to volume relationship. Remember, they can't, I won't say remember, but they cannot maintain their own internal heat like we can because there's too much surface area. So they have to go to areas where warm or cold, depending. Well, they induce a fever too, but they can't do it themselves. So if they need a fever, they will go to a warm environment. We can stimulate a fever. Fever does decrease the action of some microbes, like even syphilis. But the fever has to get too high, and when that occurs, it throws off other homeostatic processes. But it is of some benefit, both diagnostic and therapeutic. Diagnostic, seeing you have a fever, you know something's wrong. Therapeutic, it does kill some microorganisms. Okay, as we discuss a fever, let's refamiliarize ourselves with some ANP1 items. When it comes to temperature and heat in the human body, I want you to imagine that we have a surface and a core. A surface and a core. The core, when it comes to temperature, is underneath the insulator. What does an insulator do? It's a poor conductor to no conductor of what you're insulating against. When it comes to heat, what is the poorest conductor of heat in the human body? Fat. Fat is the poorest conductor. Thus, fat is our insulator. So if I go to the surface of the body, anything above the fat layer is the surface when it comes to temperature, and anything below the fat layer is the core. Well, where's the fat layer? Let's review. You had the epidermis, the dermis, and the hypodermis. The hypodermis goes by two names. Hypodermis, or subcutaneous tissue, because only the epidermis and dermis are part of the skin. So the hypodermis is under the cutaneous membrane. Cutaneous membrane is the skin. And another name for it is the superficial fascia, because it's above the deep fascia. But your fat layer is the hypodermis, has adipose cells. That means above the fat layer would be the dermis and the epidermis. Now the epidermis has no blood vessels. So basically the dermis would be the surface when it comes to temperature control. Anything below the hypodermis, deep fascia and below, would be the core. Core blood is hotter than surface because the core blood floats under the insulator. When a person when the outside temp is too hot, then you will bring blood from the core and make it more go towards the surface. You'll get redder because, remember, heat moves to cold. So the body's going to be warmer than the outside temperature under normal circumstances. And if it's too cold, you would vasoconstrict the dermis and push under the core. Now, where's the control unit for temperature? In the brain. In the hypothalamus. It's in the preoptic nuclei of the hypothalamus. The preoptic nuclei of the hypothalamus is where your control center for temperature. Now, what is normal temperature? About 98, let's say, because everything is in a range, to 100.4. Above 100.4, oral temperature is pretty much a fever, and below 99 is too cool. The median value is around 98.6 on the oral. Alright, so the preoptic nuclei has the control settings. In the skin, you have thermoreceptors in the skin. That measures the surface temperature. The blood itself flowing through the preoptic nuclei does the core. The body is looking at both core and surface, but it's more interested in core because that's where the vital organs. So what the body will do is if it's pushed to the limit in a cold environment, it will sacrifice the surface, frostbite, and so forth, to protect the core because the skin can't grow back. So that's kind of a quick run through of what we want. All right. What is a fever then? Basically, a fire starter we will call a pyrogen. Pyrogen, generator of pyros, heat. A pyrogen, like a bacteria virus, gets into the body. When that occurs, white blood cells go after it, or other cells. The white blood cells, when they go after it, will send out some cytokines. Cytokines are small secreted glycoproteins. These cytokines we'll talk about are called the interleukins. The interleukins are little chemicals that are secreted among white blood cells. So interleukins, tumor necrosis, interferons we talked about, things of this nature are secreted. These substances, so let's go back. So the pyrogen gets into the body. The pyrogen causes cells to secrete cytokines. The cytokines leak out and get into the circulation. When they leak out and get to the circulation, they go all over the body. Some will go through the circulation through the preoptic nucleus. When they go through the preoptic nucleus in the hypothalamus, they produce a prostaglandin. Remember, prostaglandin does a lot of things, known as prostaglandin E2. The prostaglandin E2 will leave out the cyclic AMP. The prostaglandin E2 then causes the neurons in the preoptic nucleus to raise the body temperature. So these right here cause the body temperature to raise. It resets the thermostat set point in the hypothalamus. So now, let's say the set point was 100.4. Now let me bring this up to you. The hypothalamus is in the core. So it's set at 100.4. That is its median value. That's its median because the core is hotter. The surface, when we do an oral, is 98.6. So the hypothalamus then, being influenced by PGE2, let's say it sets the thermostat up to 103. Now, this is what I'm saying. So now the thermostat is set up to 103. Now, let's say right now you are 100, which is still a little hot, but you're 100. The thermostat has been set now, quickly turned up, that your body needs to be 103 because the bacteria have dictated that. Now, technically speaking, you feel too cold because the thermostat has been set up to 103. You are 100, so you feel chills. Now, if somebody puts their hand on your head, they'll say, "Oh, you're kind of hot." You'll say, "No, I feel cold," because you're suffering fever and chills. Why is that? Because you're feeling cold because your thermostat has been set up. So now what's going to happen is all of those things you learned in ANP1 will cause the body to try to increase temperature. That is to vasoconstrict the surface blood vessels and start to shiver to try to increase friction. So fever and chills. When you get to 103, then you start feeling extremely tired. Now kids can tolerate 103, they can still be playing. But once you get to 103, you're lethargic. You're very hot. Now, so how did it go? The pyrogen, which was the bacteria virus, came in, caused cells to secrete cytokines. The cytokines went into the circulation and caused neurons in the preoptic nuclei. It caused endothelial cells, lining cells of blood vessels, to secrete PGE2. Prostaglandin, the lining cells of blood vessels in the preoptic nucleus area. This caused the preoptic nucleus neurons to up the temperature setting, and so you started to get hot in the attempt to kill. So high fevers are dangerous. One way is because they denature proteins. Remember, that proteins have to be in an optimal range. But what are some of the benefits? It causes the liver and spleen to sequester iron. You remember I skipped over hepcidin and ferroprotein, which have to do with iron. Increases the metabolic rate, kills certain organisms like syphilis. So that's basically what the fever does. It increases that temperature. Now, once the bacteria is killed, either by your own system or by antibiotics, then quickly there's no more pyrogen, so there's no more secretion of the PGE2, so the thermostat comes down and you start sweating profusely, trying to dissipate heat very quickly. And that's when we'll say the fever has broken. The fever has broken. Now go to one other thing here real quick. PGE2, prostaglandin. You remember we said that non-steroidal anti-inflammatory drugs, Motrin, Advil, even aspirin, will inhibit the enzymes that make prostaglandins. So that's how that they control the temperature when you start having a fever, is they act as a inhibitor, enzyme inhibitor, preventing PGE2 to be adequately produced, and thus that's how you modulate the temperature. You modulate the temperature. Now, I'm just going to mention one last thing, fever versus hypothermia. A fever is where the thermostat is set. A fever is where there's an increase in the thermostat. Hypothermia also raises body temperature. Point to bring out. We produce more heat than we need. We produce through metabolism more heat than we need. So our body is generally under normal outside temperatures under a heat dissipating modality. If for some reason you do not allow the heat to be dissipated, let's say you got a hot coat on, it's already summer or something, then you will start to increase temperature, not because the thermostat has been raised, but because you could not dissipate the heat. You could not get rid of the heat, both of which can cause major problems. So that's what we talk about, a temperature, the fever, and to kind of give you an idea of that. All right, we'll close here.